Hi, welcome back. Now we are going to see the quotient if we are going to divide this function f of x by the function g of x. So f of x is x cubed plus 4x squared plus 3x minus 6 to be divided by the g of x, which is x minus 2. Now, in the previous examples of division of functions, we're able to use the factoring, or we're able to factor out specific portions, specifically of our numerator, and see to it if there are terms or binomials that could be cancelled using our denominator. But here, it would be very taxing for us to still factor this. So we are going to use here the usual division of polynomials. Now we have that what we call as long division of polynomials, but we are going to share here another method of dividing polynomials we call synthetic division. The synthetic division will give us a result, the quotient, at the same time as the remainder when we divide two functions in this manner. Let us try to pick the coefficients, the numerical coefficients of the dividend. X cubed is 1. Okay, 4x squared is 4. Okay, next 3x is a 3, and you have your constant of minus 6. We're going to line them up in this manner, and we are going to place here a certain c. That c is the c of your divisor. Our divisor here is g of x in this manner, x minus 2. Okay, this is our divisor. The item that we are going to place here is in the form of x minus c. Whatever be the value of that c, we're going to place c here. Since our divisor is x minus 2 and we're looking for x minus c, automatically we could say that c is just equal to positive 2. Positive because then again, the divisor is x minus 2 and we're looking for the value of c for x minus c. So it patterns like that. C is equal to 2. We're going to place here 2. Now, these are the two requirements for your synthetic division. Again, the coefficients of your dividend, and then here, a certain c, which refers to the c of your divisor. The process of synthetic division follows this. Okay? Let us try to bring down the first coefficient 1. And then we're going to multiply the result here by this certain c. So 1 times 2 is positive 2. Now, after here, we are going to add the certain coefficients. 4 plus 2, I have here 6. So, after that, we're going to do it again. 6 will be multiplied by 2. So, 6 times 2, I have here 12. Okay? So, doing the same process, 3 plus 12, I have 15. Okay? And then finally, 15 times 2 is 30, and if we're going to add this, I will have here 24. Now that is the process for synthetic division. These are now the coefficients of your quotient, except for this final here. This is your remainder. Okay, this is your remainder. These are now the coefficients of your quotient. Take note that the given dividend has the highest degree is 3. That's why it's x cubed. If we're talking about the quotient, this would be n minus 1. n minus 1, talking about the exponents. So if our n is cubed earlier, this would be the coefficient of your x squared. Hence, the quotient is 1x squared. Okay? 1x squared. Since this is positive, I have here plus 6. The next term here would be x. This would be your constant plus 15. So this is now your quotient with remainder of 24. This is your remainder. Now, if we are going to combine them into one expression, we can simply add this one here, the remainder. But when you are going to express your remainder just like this, when you divide 3 by 2, your answer here is 1. Okay, and your remainder of 1, right? Because when you divide 3, long division by 2, you will have here 1. So that's 2. You have here 1. This is your remainder. Okay? But if you're going to write it, it's actually 1 and 1/2. That's basic division. This patterns this. 1, your quotient, and 1/2, remainder over divisor. In this manner, you have your quotient, then you have plus your remainder over your divisor. Okay? We're using plus here because basically 1 and 1/2 is 1 plus 1/2. So similar here, this was our quotient earlier. So plus your remainder of 24 over our divisor of x minus 2. Notice we use plus here because this is positive 24. If in case this is negative 24, we're going to use here minus. So this is now the complete result when we divide f of x by g of x using the given functions. We have x squared plus 6x plus 15 plus 24 over x minus 2 using the synthetic division. That's all for today. You're dismissed. And please do not forget to subscribe now.